Hi, hello everyone. This is Nepal Reddy sir from ANR Academy. Today we are going to discuss how to find the equation of reflected ray when incident ray as well as mirror equation both are given. Suppose that an incident ray whose equation I am going to write Li notation, and the equation suppose that a1x plus b1y plus c1 equal to 0. This is the equation of straight line. It is incident ray, and suppose it strikes on mirror whose equation suppose that ax plus by plus c equal to 0, general equation of straight line. Then how to find reflected ray? That concept we are going to discuss today. And here the diagram. Suppose that this is mirror line, and assume that incident ray here, if it strikes on the mirror and then it reflects, suppose the reflected ray this one is reflected ray. If both the equations incident ray as well as incident line or incident ray whatever it is and mirror line, if both given, then how to find this reflected ray, that we are going to discuss. And here the equations I am going to mention in the diagram. This is known as mirror line, ax plus by plus c equal to 0, and it is incident ray, so that it is Li equal to 0, a1x plus b1y plus c1 equal to 0. Now the aim is to find reflected ray, Lr. See this figure, just if you extend incident ray as well as if you extend reflected ray, then you will get the diagram like concurrent lines. These three lines are passing through one common point, so the lines are concurrent. So here I can use the concept of family of lines. You know that the concept of family of straight lines. If L1 equal to 0 and L2 equal to 0 are two intersecting lines, then the combination of family of lines passing through the point of intersection of both lines L1 and L2, that is denoted by L1 plus lambda into L2 equal to 0. The same concept I am going to use here, where lambda belongs to real number. Here there are two lines. This is first one. Suppose that this is second one and this is first one. Incident ray I am going to select equation 1. Reflected ray, suppose that is equation 2. And from the intersection of Li as well as Lm, Lr passing, right? So I can use the family of lines concept, and Lr can be written as, clearly that is combination of Li and Lm, so that with the help of the concept of family of lines, required line reflected ray I am going to write Li plus lambda into Lm, it is equal to 0. So with the help of family of lines, the formula, using this formula L1 plus lambda into L2 equal 0, this is LR. So here there is only one unknown, that is called as lambda here. Just by calculating the value of lambda and writing given Li Lm, you will get reflected ray. So here the main aim is to find the value of lambda. Let us see. And to find the value of lambda, you have to use one geometrical condition. There is only one unknown. For that, you have to use one geometrical condition from the figure. Using that condition, you can eliminate the value of lambda. See, to find the value of lambda, I am going to select one geometrical condition. Observe carefully. Suppose that here there is a point alpha comma beta. I am going to write there is a point alpha comma beta on mirror. Suppose this is the point alpha comma beta, and from this point I am going to drop a perpendicular to the incident ray as well as reflected ray. First, drop a perpendicular from any point on the mirror to first Li, that is incident ray. Next, I am going to drop another perpendicular here. These two distances are same. You may select any point, any one point on the mirror. From that point to incident ray as well as reflected ray, the distance is same. And here mirror acts as a angular bisector of Li as well as Lr. Next, so using this geometrical condition, distance from any point on mirror to the lines incident ray as well as reflected ray, the distances are same. Using that condition, I am going to eliminate the value of lambda. First, Li plus lambda into Lm equation I am going to write. Assume that first alpha comma beta point on mirror. What I am selecting to find the value of lambda, let alpha comma beta be a point on mirror. Mirror equation given ax plus by plus c equal to 0. So whenever you select a point alpha comma beta on mirror, the point satisfies the equation, so that a alpha plus b beta plus c result, that is 0. Next, I am going to write geometrical condition. To find the value of lambda, we are going to use this condition. What is that condition? From this figure, distance from alpha comma beta to Li is same as distance from alpha comma beta to Lr. Yes, I am going to write the condition here. Distance from the point alpha comma beta to the line Li is same as distance from the point alpha comma beta to the line that is known as reflected ray. But this reflected ray, using the family of lines written as Li plus lambda into Lm equal to 0. This is Li plus lambda into Lm equal to 0. With the help of this geometrical condition, I am going to write distance formula. Point to Li. You know that the distance from a point x1, y1 to a general line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root over a square plus b square. The same formula I am going to apply here. Distance from alpha comma beta to this line a1x plus b1y plus c1 equal to 0 first. That is, here we get modulus of ax1 plus by1. I think it is a1x plus b1y. See, yes, it is a1x plus b1y. So that a1 x1, the point alpha comma beta, so that in place of x you have to replace alpha. a1 alpha plus b1 beta plus c1 whole divided by root over a1 square plus b1 square. Left hand side, it is the distance from alpha comma beta to Li equal to 0. I repeat, left hand side, distance from alpha comma beta to Li, that is modulus of a1 alpha plus b1 beta plus c divided by root over a1 square plus b1 square. Next, in the right part, distance from alpha comma beta to reflected ray. Reflected ray whose equation, that is the combination of Li and Lm. So first Li incident ray, in which the point alpha comma beta you have to substitute a1 alpha plus b1 beta plus c plus lambda into Lr is combination of both Li and Lm, lambda into Lm. Lm, that is mirror equation ax plus by plus c equal to 0, so that a alpha plus b beta plus c you have to write in the numerator whole divided by root over coefficient of x whole square plus coefficient of y square in the denominator part. Here coefficient of x become a1 alpha, coefficient of x, that is a1 plus lambda into a. Yes, a1 plus lambda into a whole square plus b1 plus lambda into b whole square. In the distance formula, in the denominator part you must have root over coefficient of x whole square plus coefficient of y whole square. Here, due to Lr, combination of Li and Lm, coefficient of x in Li, that is a1 plus lambda into next coefficient of x in Lm, that is a. So a1 plus lambda into a whole square, a1 plus lambda into a whole square. In the same way, y coefficient b1 plus lambda into b whole square we get. And observe here the value of a alpha plus b beta plus c, that is 0. Clearly this one is 0. When it is 0 and these two terms gets cancelled, a1 alpha plus b1 beta plus c left side, and the right side the same in the numerator part a1 alpha plus b1 beta plus c, and hence you have to equate the denominator part. So by equating this we get a1 square plus b1 square equal to, expanding this we get a1 square plus lambda square a square plus 2 lambda a1, next plus b1 square plus lambda square b square plus 2 lambda b b1. a1 square b1 square, a1 square b1 square, both the sides gets cancelled, and we get, also you can neglect lambda from the remaining 4 terms. Neglecting lambda you will get lambda a square plus b square one lambda outside, lambda of a square plus b square, next plus 2 times of a1 plus b1 equal to 0. Therefore, lambda either 0 or minus 2 of a1 plus b1 whole divided by a square plus b square. Here, when you put lambda equal to 0, what happens, observe, if the value of lambda equal 0, what we get? Again Li. Li is not reflected ray. So, lambda must be non-zero quantity. Here, lambda non-zero quantity. So, you have to write lambda value r minus 0 here. Yes, this is not applicable. This one gives reflected ray. So that in the next step I am going to write reflected ray. Actually, reflected ray, that is combination of Li and Lm. So now I can write reflected ray. First Li, incident ray, a1x plus b1y plus c1 plus lambda value. Here you have the value of lambda, that is minus 2 of a1 plus b1 whole divided by a square plus b square multiplied by next mirror ax plus by plus c equal to 0. So you can use this formula to find reflected ray. Let us discuss one of the problems first based on this. Suppose that there is a question given that a ray of light sent along the line x minus 2y minus 3 equal to 0, upon reaching the line three x minus 2y minus 5 equal to 0, then it is reflected. The question is, find the equation of reflected ray. This is the question. Here, a ray of light sent along the line x minus 2y minus 3 equal to 0 is given. So that is known as incident ray. You know that incident ray general equation a1x plus b1y plus c1 equal to 0. So that here the values of a1 1, b1 minus 2, c1 minus 3. Next, and upon reaching the line 3x minus 2y minus 5 equal to 0. So that after that it is reflected. So this is known as mirror line Lm, and this is incident ray Li. Now generally Lm written as ax plus by plus c equal to 0. So that here the value of a3, b minus 2, c minus 5. You have a1, b1, c1, abc values. And we know that in our earlier discussion Lr, first you have to write incident ray. What you have incident ray? x minus 2y minus 3. So here x minus 2y minus 3 plus lambda multiplied by image, lambda multiplied by mirror equation 3x minus 2y minus 5, 3x minus 2y minus 5 equal to 0. Next, here lambda value minus 2 multiplied by, in the numerator, a1 plus bb1, a1 plus bb1, 3 into 1 minus 2 into minus 2, 4 plus 4, 3 into 1 3, next minus 2 into minus 2 plus 4. So that what we get? That is 7. 3 into 1 3, minus 2 into minus 2 4. Next, in the denominator part, you have to write a square plus b square, 9 plus 4, that become 13. Here you have to write 9 plus 4. What happens? X minus 2y minus 3 minus 7 into 2, 14, divided by 13 of 3x minus 2y minus 5 equal to 0. You have to simplify this. Here, multiply with 13 and divide with 13. What we get? 13x, 26y, 39 minus 42x, it is minus into minus plus sign, 14 to ja 28. Next, 14 into 5 minus minus is there, so plus sign 70 equal to 0. Now you have to simplify this. From 42 you have to remove 13, that is minus 29x. Next, plus 28 minus 26 gives plus 2y. Next, 30 minus 39, that is plus 31 equal to 0. So that finally what we get? 29x minus 2y minus 31 equal to 0. This is a reflected ray. One more question we are going to discuss. Suppose the question is, suppose incident ray, this one, it strikes x-axis, not the line, not general equation of line, simply x-axis is given. It strikes x-axis at the point P and then it reflects. And incident ray which is passing through the point 1, 1, reflected ray that passes through the point 3, 1. Then find coordinates of P. This is the question. See this question. There is an incident ray which is along the point 1, 1 and that strikes x-axis at the point P and then reflects, and the reflected ray passing through the point 3, 1, then how can you find the coordinates of P? Not equation of reflected ray here, only the coordinates of P, x, y here we need to find. Clearly on x-axis y always absent, so y coordinate become 0. Without using previous result, a simple approach, observe in this, just extend reflected ray. What happens? You will get image of 1, 1 with respect to this x-axis on the reflected ray. Here, to reach the point 1, 1, you have to move 1 unit towards x-axis and 1 unit in the upward direction of y-axis. Here, to get image, the same on x direction 1 unit, but in the downward direction you have to move, so that This is image of 1 comma 1 about x-axis, and coordinates of P, x absent, y absent, x present, y absent, x alpha, y 0, I am going to select P. Now observe from the figure, these three are on the same straight line, therefore they are collinear. Collinearity condition, when 3 points are collinear, then 3, 1, 1, alpha 0, 1, 1, minus 1, 1. Its determinant becomes 0. On solving this, we get the value of alpha. Minus plus. Here, on solving it, 3 multiplied by 0 plus 1. It is 1. Next, minus alpha multiplied by 3 minus 1, that is 2. Next, plus 1 multiplied by just 1 equal to 0. 3 plus 1, 4, minus 2 alpha equal to 0. 2 alpha value 4, alpha value 2, and hence you can write coordinates of P x comma y alpha comma 0 become just 2 comma 0. So that is your answer. So in this way we can approach the problems based on incident ray and reflected ray. I hope you understand everything. The students, those who are aspirants of JEE, please watch my channel and share the videos to your friends, as well as the students, those who are interested to write JEE mains, please forward them. Thank you so much.